This is Professor Bob Young again, and in this instructional video, we are going to solve formulas. Now, not only will you need to do this in mathematics courses, but you'll also need to be able to solve formulas for many of your nursing courses, science courses, and other fields of study. So this is one of the most important things in math that you can do. So again, I'm just refreshing your memory on when we solved equations, just getting numerical answers or no answers or whatever. Here is what we did, the 5 steps. Okay, so keep that in mind as we move on here, and we're going to start with this next problem here. So this is the interest formula that your banker loves to use here. I equals PRT, with I being interest, P being the variable for dollars here, principal it's called, R rate, and T time in years. Okay, so your banker loves to use this formula on you for your home mortgages, car purchases, credit cards, and you say you never use math in real life. All right, so they'll give us this equation here, and what they'll ask us to do is go ahead and solve for another variable. Let's say we've got I equals PRT here, and we want to get T by itself. So you can see, if we want to isolate T here, what we're going to do is have to get rid of what? The PR. And since all of this means multiply, we're going to divide both sides. So notice again, BS is involved here by P over R. So time in terms of those variables would be interest divided by principal times rate. Now, what a lot of instructors will never show you is there is a way to actually check and make sure your formula is right here as well. So let's take the original formula here, and we'll just put some real easy numbers in for P, R, and T. I'm going to let P be 1, R be 2, and T be 3. 1, 2, 3, as easy as do, re, mi. And hopefully you'll say, well, if I multiply principal times rate times time in this basic example you're giving, Young, I would get 6 for the interest. Correct? I would hope you stay correct. So we're going to go down here and check our formula. And if we did it right, all of this should make perfect sense. So I'm going to plug in what for T down here? 3 equals, we said I was 6. And P and R was what? 1 times 2. And notice if we say 6 divided by 1 divided by 2, it does check and it'll make perfect sense. So whatever you end up with for whatever variable you're solving for will make sense as well. All right. Let's try another one here. Oh, one with fractions. Are you shaking? Are you going, Mama, Mama? Well, don't get scared on this one because we've already talked about how to get rid of fractions. Even in formulas, it'll work. Multiply both sides by, you know what, the LCD, which in this case, there's only one denominator. We're going to multiply both sides of this creature by 2 to get rid of the fraction. So always get rid of fractions first. So 2 times S equals GT squared. So 2 times a half will give us 1. The 2's will chop, chop out. Now, how do I get G by itself? Well, let's focus in on this guy. That's what the first frame said to do. We've got to get rid of T squared. How? And hopefully you're saying, well, since they're multiplied, Young, I know how to attack multiplication, solving all these equations. We're going to divide both sides by T squared. So even with fractions, you can solve and get these variables by themselves. So don't think these are any worse than just solving numerical equations. You'll need to do this in many of your courses in college. All right, let's take one that's a little bit more interesting here. This formula gives the future or maturity value of A of P dollars invested for T years using this formula here. And again, A is going to be the future value, P is the principal, R is the rate, and T is the time in year. So the formulas, I'm afraid, will get a little worse. Now, in this case, they want us to solve this formula here for P. And look at here, since P is on the outside of the parentheses and it means multiply, all you have to see on this one is, hey, what do I do to get P by itself? I'm going to divide, and we can divide both sides by this whole quantity. So that was not as bad as you thought, huh? And there is your answer. Now notice that you can write it with the P on the right side or the P on the left side. It doesn't matter. I mean, P is still going to equal, no matter which side you move it on, the same thing. Okay? And again, if you took and plugged in numbers here for P and R and T, and you picked real easy numbers and got a number here for A, it would also make sense down here in your answer for that equation. So keep that in mind as we progress. And now we're even going to solve more nasty type formulas for certain things. Now notice this one says solve for X, but there are X's, ladies and gentlemen, on both sides of the equation. So sometimes students will say, holy cow, Young, what are you talking about here? So what we're going to try to do is get all the variables X on one side and everything that doesn't have an X on the other side. And I hope that makes sense, because that's what we were doing when we were solving for X long ago. So notice our rules for equations do not change. We're going to distribute first, okay? Even if we've got a whole bunch of letters in there, we're going to multiply the 3 through here to get 6x minus 15. And then what? We're going to take everything that has an X. So I'll stay with blue here. Everything that has an X, we want to move to one side of the equation. So I'm going to say this is like LL, letters left. Now I know this one has a bunch of letters in it, but this is the letter we're after, is X. And everything that doesn't have an X, we're going to move to the right. So to take out a minus 15a, we're going to add 15a BS, both sides. To take out a minus 4 or a plus 4b, we're going to minus 4b from both sides. So notice this is what we're left in this next statement, and then we can of course combine like terms, putting 6x minus 4x together to get 2x, and then dividing by 2, here is your answer. So again, formulas are just another form of BS. Whatever you do to one side, do to both sides. All right, let's try one more example and we'll finish off this formula section here. Now, what would y'all say do if you were solving this formula for a specified variable? And I tell you what, let's solve this for X. Solve this for X. Well, what we're going to have to do, great Scott, we're multiplying binomials over here, Young. We haven't seen this in a while. And from your previous courses, you should know whenever you multiply binomials, it's FOIL time. Y'all remember what FOIL is? First, outside, inside, last. So if we FOIL this, we're going to get 2x times m is 2xm, or mx, whichever way you want to write it. The outside two terms are always the ones farthest apart, so good little review here, plus 8x. The inside two are the ones closest together. Minus 1 times m is minus 1m. And then, of course, the numbers minus 4 equals 3x. Okay, now if we're trying to solve this for x, everything that has an x must go to this side. So again, if it's got an x in it, we want to get it on one side of the equation. So in this case, we're going to go ahead and subtract 2xm. And we're going to subtract 8x from both sides. So everything that's got an x is now on the left side of the equation. So here's where we're going to be next. And you can hum and have fun as you do these. What next, Young? What next? So we've got to collect like terms. We've got a 3x and we've got a minus 8x there, which I believe will add to be minus 5x. Minus 2xm equals minus m minus 4. Now tell me you didn't try to put those two things down here together, because they're not like terms. Now still, we have to get to x. How do we do it? Well, we're going to have to factor an x out of this one. See, this one you can't put together, so you have to think about taking it apart. So if we take an x out, this is like undistributing, we're going to get minus 5 minus 2m equals minus m minus 4. And now that we've got x isolated, this is the toughest one when students have to factor. You can divide both sides by this statement. Now, I don't like all these negative signs in this answer down here, do y'all? I mean, so we would have x, because these would cancel out, equals all of this. Now, a lot of textbooks and science books don't like a lot of negatives, so what they might do is just multiply both top and bottom through by -1 to make this look prettier, okay? So what that would do is just make this answer a little prettier. We would get x equals m plus 4, all the signs would change, over, let's put 2m plus 5 in the bottom. What do you think? So that is like one of the nastiest examples of formulas here. All right, and then we can actually use this in real life here, applying this interest formula. Let's say LaToya Johnson borrowed $5,240 for new furniture. She will pay it off in 11 months at an annual simple interest rate of 4.5%. How much interest will she pay? How much will they make off of her? Now notice we had to change the time in this one to years, all right, because it said 11 months. So we had to change the time to 11/12 of a year, which I don't know why this example picked that, but they did. And then it's kind of like the Glade plug-in commercial. Plug it in, plug it in. So knowing the formula, we're going to plug in the P is 5,240. The rate in decimal form, 4.5%, would be, great Scott, that looks like a mistake to me. I do think that's a mistake here in this graphic that I took here. I think this should be 0.045%, because when you change a percent to a decimal, you must move it 2 places to the left, and then times the 11/12. So I think there's an error here in this graphic, so let's fix that. And you should come out with this answer, $216.15 interest. So check that on your calculators, and if it's not, I want you to tell me in class and scream bloody murder. All right, so that is a review of formulas. Bob Young signing off.